Okay, let's restart. So the answer of the poll is spread between option A and B and C, and the result of this experiment where, maybe I need a little bit of the background for this. So what they did was that after operation of this rewiring of the ferret, right after the birth, then they started to raise this ferret in a normal environment, but they only showed the stimulus to the right visual field for which, so they operated this only for one side of the hemisphere, and the other side of the hemisphere receives a normal kind of the input, and then using this normal hemisphere, they trained the ferret to respond to press the button here. Oh, I saw the vision, and then oh, I saw auditory tone, and so on. And then that's very, because it's so different. It's very easy to train the ferret. And then once the ferret understands this task, then for the first time they present the input into the the rewired cortex, and then ask them which one did you experience, vision or audition. And then what they found was that in this case, even though visual cortex is not involved, the rewired A1 animal said that it was visual sensation. Okay. Of course, we don't know exactly what the ferret is experiencing, but this kind of thing is potentially we can address in the people who are rewired in terms of sensory substitution that some of you guys reviewed in the Journal Club and so on. So it's not impossible kind of experiment, and many things can be done in the future. So let's move on. So in summary, the first part says that we need the theory of consciousness because the field has matured enough to accumulate a lot of experimental findings. And many theories have been proposed to explain various aspects of consciousness. But if you ask, is there any theory that can link the difference in neural connectivity patterns and specific and unique nature of chorea, then the answer would be integrated information consciousness. Is there any questions so far? Okay, so then otherwise, let's move on. So the next question is, I've been mentioning this, a long time, but finally we came here. What is the integrated information theory of consciousness? So integrated information theory of consciousness, IIT, is a theory that starts from consciousness, then seek for what kind of mechanism in the brain can support consciousness. And this is very different from other theories, which tend to start from the brain and then hope what kind of brain mechanism will explain consciousness. Okay, so the idea is opposite. So our path so far, up to week 9, has been always like this, so-called easy problem, approach according to some philosopher, explain some kind of observable behaviors or reports from neural activities. And then we kind of started to challenge this from a no-report paradigms. But then trying to find the correlational evidence between the consciousness and neural activities. But we also try to go beyond the correlation by causing activity in the particular areas of the brain. And then the so-called hard problem of consciousness is this way of transformation of this explanation. You see something in the outer world, and then something in the brain happens, and then that particular type of the neurons, let's say medial temporal lobe, corresponds to or generates this dog conceptual experience. That's one. But the problem why this is hard is that this gap of going from mapping NCC to understanding consciousness, and here there are philosophers put some arguments such as zombie arguments or inverted qualia or knowledge arguments. I don't go into the detail. And these are their argument or basis of why we cannot do this. basically, it seems it's pretty arbitrary. Why do we perceive face or color motion? Because neurons in FFLB8 or MT are stimulated. There seems like there's too much gap in the way to explain. So philosophers just deny this kind of explanation. Okay, and integrated information theory is a different kind of approach. And the way they do is the following. So although there's a unreachable gap here between the summit and also top of the mountain to path to the mountain summit, IIT goes in a sense, try to get to the problem, in the first place, just using a helicopter, and they land it on directly. And that's the kind of a strategy proposed by Giulio Tononi. And the IIT tries to come up with the explanation of how our conscious phenomenology can be supported by physical mechanism. Okay, it's not like starting from brain to think about the emergence. It's not rather how this emergent phenomena can be potentially generated by particular type of the neural activation. So in other words, it's the reversal of this arrow. Okay. So in summary, if we start from the observation of a neural activity, then we end up with explaining ABC problem, how stimuli or reports correlate with the neural activities, and also getting stuck at the so-called hard problem. And the alternative theoretical option is to start from the phenomenological properties, and that's the IIT's way. And then the next question is that what are the essential properties of consciousness that is true for any experience that you may have that IIT considers? So far, is there any question? Okay, then let's move on. What does IIT identify as essential properties of consciousness? So according to IIT, essential properties of consciousness that's true for any and each of conscious experience is first, it's intrinsic, meaning that it exists for some entity that is experiencing that thing, consciousness. And then the second is that the composition, third is information, fourth is integration, and the fifth is exclusion. Second to fifth, I'll explain a bit later. So let's go into a little bit of the detail. What does it mean that consciousness is always intrinsically existing? And according to this Tononi's way, when Tononi thinks or sees his foot in the room like this way, and the sketches provided by Ernst Mach in 19th century, it becomes clear introspectively, according to Tononi, that consciousness exists. Each experience is actual. Indeed, my experience here and now exists. It is real. It is the only fact I can be sure of immediately and absolutely. This reminds me of the, maybe you as well, Descartes, cogito ergo sum, that I think or I experience, therefore I am. So this is a kind of the most fundamental facts about conscious experience. It is not something that you observe about other people, or it is something that other people evaluate on me. It is me who is experiencing that thing. Moreover, my experience exists from its own intrinsic perspective, independent of external observers. So that means that my conscious experience exists regardless of whether other people are surrounding me or not. We discussed this kind of thing in a locked-in syndrome patient as well. The second component is a composition. Consciousness is structured. Each experience is composed of multiple phenomenological distinctions, elementary or higher order. For example, within one experience on the left side, for example, I may distinguish a book on the left side, blue color and blue book, And also it is located on the left side, a blue book on the left, and so on. So it is kind of hierarchically organized and composed of many different kind of components, and then it can be combined and specifying one particular experience. And then third one is informativeness or information. And here it is one particular experience out of many experiences that is depicted in here. So consciousness is specific. Each experience is the particular way it is, being composed of a specific set of specific phenomenal distinctions, thereby differing from other possible experiences. And this is sometimes also called or conceived as a differentiation. And this is a bit difficult to imagine, so I'll just give you a bit of the more intuitive explanation. So if you think about a single photodiode, then it has a state of on or off. If it detects light, then it becomes on, and if it doesn't detect the light, then it becomes off. And this kind of one component of the thing becoming on or off is counted as one bit of information. And then if you think about or extend this thinking into the single neuron, then you can also think about single neuron firing or not firing as one bit of information potentially, right? But what's different between a single photodiode and the brain is that the brain contains 86 billion neurons or 10 to the 11 neurons. So at least it seems like 10 to the 11 bits or something like that can be happening. So massive information seems to be possible with the case of the brain, but not in the case of a single photodiode. Next, integration. So consciousness is unified. Each experience is irreducible or decomposable, not decomposable, to non-interdependent disjoint subsets of phenomenal distinctions. It sounds a bit strange to think about the composition, but I'll leave it for now. Thus, I experience a whole visual scene, not the left side of the visual field, independent of the right side. So no matter how you try to attend or intend, you just cannot experience only the right side of the visual field, or only color aspects but nothing else, or motion aspects but nothing else. That's just impossible to do. When you experience something, it comes as a whole. That's this integration aspect. But this is not super immediately clear why this has to be the case if you think about the brain as an architecture. Because as I have already explained, the color and visual motion and face and the concepts are supported by different areas of the brain's neurons. So if always this has to come to this integrated experience, there must be some kind of phenomenal mechanism that supports this integratedness. And what is that? That's the question IIT tries to answer. So to try to understand a little bit better about what this integration means, another thought experiment is a digital camera versus human brain. So digital camera can have a huge, maybe I should actually update this with the iPhone or something like that. But the upshot is that these camera or photographs device can have a huge number of the pixels, and each of the pixels can independently capture the amount of light, and then that results in this nice picture, picture that you take with the iPhone all the time. But the critical thing here is that in each pixel in the camera or iPhone, they are independent. It means that even though one particular area of pixel is black and then surrounding pixel is red, it doesn't override that black input must be red. Some of the very intelligent device might do that in the future, or maybe in current some of the application might do that, depending on the Snapchat and things like that, Snap camera and things like that. But in principle, camera or artificial device does not interfere with each other. or integrate the information between them. And each of the pixel work independently, and that's the way they capture the external environment in a faithful manner in the camera's screen. But brain is not like that. As you have already learned, each neuron is connected to 1,000 to 10,000 of the other neurons, and they are interacting all the time. So even if one neuron wanted to say that, oh, I see something, but if it's surrounded by other neurons that says, no, you didn't see it by inhibition and so on, then it cannot freely, fire as it wish. So that's the sort of the integrated nature of the brain compared to the digital camera. And then finally, exclusion. Exclusion is that consciousness is a definite in terms of content and space and time. Each experience has a set of phenomenal distinctions. It has neither less or nor more, and it flows at the speed it flows, neither faster nor slower. So this figure on the left shows that conscious experience cannot be less of what you have. So this is the black and white version of the same thing, same experience. We cannot have that. And also this one is a blood pressure of a particular parts of the brain, body. You also cannot be conscious of blood pressure of somewhere, In a very, limited case, you might be able to, experience some parts of the brain, bodies, state in some way, but usually not, it's possible. So there's a boundary or border of consciousness. Within that, you experience everything, but outside of that, you don't experience. That's the kind of the idea of this exclusion. So from these phenomenological actions, IIT proposes that large quantity of integrated information corresponds to the high level of consciousness, and largest cluster of integrated information is the same, the locus of consciousness or boundary of consciousness. And then finally, distinct quality or pattern of structure of integrated information corresponds to each experience or particular query. So some kind of structure of integrated information corresponds to some particular type of query, like a color or face or motion. So in summary, IIT starts from 5 phenomenological actions, and then IIT proposes a physical mechanism that can support the essential properties of consciousness. This part I haven't actually explained in detail. And then it tries to quantify, delineate, and specify consciousness. But the next question you might ask is, how can we compute this integrated information? I haven't actually explained anything about that. So that's the next component. So is there any questions so far? Is it too fast or okay? Okay. All right. All right. So let's go to the next part. So how can we compute integrated information? So integrated information can be actually computed in relatively simple systems. And that's not super difficult to understand. Understanding how it works in a simple systems would give you that some ideas of how to estimate integrated information in the real brain. And also key ideas are information and also integration. Okay. And we will use a simpler version of IIT to introduce the key idea. And then that's the one that I explained in this, a paper, Philosophy Compass, and in the reading material. This is written for the philosophers, so it should be easy to understand without any math background at all. So overall idea behind the integrated information is the following. First step is to determine all possible states for subsystem or system that can take. Okay. In the case of photodiode, if it's one photodiode, it's either on or off. And in the case of one neuron, it's a firing on off. In each case, it's two states. Okay. And then from here, it's a bit complicated, but it's not that difficult. Second step is determine how much of its future or past states are constrained or determined by its current state. And that is called intrinsic information. I'll give you an example in the next slide. The thirdly, eventually you evaluate how much the system will change or will lose when the system is minimally cut. And this loss of information by the minimal cuts, that's the integrated information. Okay. So let's go from the first one. We first started with just one neuron, but that's super, easy, and there's nothing to gain. So we'll think about the minimal situation with the two neurons. Okay, that these two neurons are connected in a way that copies its state into the other, neuron with one-time delay, and it can take either on or off. Okay. So if the current state of neuron A is on, from this, can you tell me what was the state of the neuron B in the past? It's 50-50. Can somebody? Oh, yes, exactly. Because it's on, now it's on, right? And then if the current state of this guy, neuron B, is off, then what's the state of neuron A in the future? Off, exactly. So it's simple, really simple, right? And so one step before is that if you think about all possible states that this two neuron system can take, then you'll realize that, oh, okay, so neuron A itself can take either on or off, and the neuron B can take either on or off. So in total, there are four possible patterns, right? Easy. Then as a sort of the advanced kind of, question, what happens if there is neuron A and B and then C? Each of them can be either on or off. How many states are there for this, three neuron system? 8, exactly. So basically, the equation here is that if the number of the states of each neuron is 2, and then the number of the neurons are n, 2 to the n is the states of the system that it can take. Okay? So far, any question? Fine. Okay. So stop me if you're lost. All right. Then let's consider a simple example. The current state is on and on, or on and off. And then, as you already answered, A and B, the future is completely determined because of this copy and copy mechanism. On off becomes off on, and also past state has to be also off on to be on off right now, right? So with all of this, now you understand. Let's compute the intrinsic information of this system AB. First step is how many possible states for this system, neuron AB, that is embedded in the brain. Okay, you have a huge number of the brains here, but you take this neuron AB system right now. And then how many states do you have? X states. And then how many possible states can you take in the next time step given the states in the current state? So if the current state is off on, then what's the state, number of the states that it can take in the next step? So with this, I'll take another 4-minute break, and then we'll come back from this answer. Please type in the chat for your answer. It can be a private chat mode or sent to everybody. Either way is fine. Basically, the question is, what are the X and Y and Z?